Hi and welcome to EatMind Academy. This is Pawel Potasinski and you're watching the 4th episode of Snowflake on Azure series. Today I'm going to talk about virtual warehouses. They are the power of the Snowflake platform, so they provide you compute that you can utilize to run your workloads, to separate your workloads, and to do many things in parallel. You really need to understand how virtual warehouses work so you could efficiently work with Snowflake and optimize your cost of the platform. With that, let me show you how virtual warehouses work. So let me guide you through virtual warehouses in Snowflake. And let me start with reminding you how Snowflake works. So in Snowflake, you have your databases. You can have multiple databases within a single Snowflake account. The logical model, the security, and the metadata of the databases and their tables are maintained in the global services, global metadata services layer, so it's completely separated from the storage. Just as the compute power. So virtual warehouses are your compute power for dealing with Snowflake and running queries on top of your data. You can have multiple or as many as you can. As many as your wallet allows you, virtual warehouses to run your queries, to run your workloads. You can separate your workloads. To give you an example, you can run a dedicated virtual warehouse, small virtual warehouse to run your ELT processes, to load the data into your databases. As well as you can run different ELT or ETL tools to assist you with loading the data into Snowflake, but they can use dedicated virtual warehouses for that. At the same time, you can connect to Snowflake using different BI tools, but they can connect to dedicated warehouses. Moreover, you can create as many warehouses as the number of your departments to provide a separate virtual warehouse for each of the departments. And if you have a dedicated analysts or data science team, you can provide them as well a separated virtual warehouse just to make sure that the workload will perform appropriately. Now, as you can see, the size of virtual warehouse is assigned with the t-shirt size. So starting with X small, medium, large, and for X large, the biggest, they just scale by the multiplication by 2. So X small is twice smaller than small, medium is twice larger than small, and so forth. Now, when you create a new virtual data warehouse, you just have to keep in mind that creating this one using Web UI is quite different than creating from the code. If you run the SQL statement, create warehouse, you will create by default the X small virtual warehouse. While when running Web UI, by default you are creating X large, which can cost you money. Additionally to that, using create warehouse, you can specify that the newly created virtual warehouse will not run by default. While in the Web UI, the newly created virtual warehouses start working by default, so they actually can cause some cost on your side. Now, it's not only about creating multiple warehouses in Snowflake. It's also about the way how you deal with scaling up and out. So whenever your data science team runs some sophisticated machine learning algorithms, they may require more power than small virtual warehouse provides. And in this situation, you can easily scale up for performance virtual warehouse in Snowflake to make sure that the performance will be good enough. At the same time, you may expect that over time the number of users consuming the data from Snowflake will increase. And you will, of course, suffer from unexpected peaks like Black Fridays. So to deal with them, you can use the power of scaling out for concurrency. So whenever the number of users grow, the multi-cluster architecture will respond with scaling out automatically So you can specify that virtual warehouse will actually react, will behave reactively in order to deal with growing concurrency. So let me actually show you how those two features, scaling up and scaling out, work, and also how you can create virtual warehouse as well. So here I am in Snowflake Web UI, and the first thing I'm going to do is to move to the warehouses and to show you that I have already created two warehouses, but I'm going to create the third one. And as you can see, the default size, as I mentioned in the slides, is the X large one, which is pretty much expensive. So normally I would encourage you to definitely change that into, for example, X small. So the strategy is start with the smallest, and eventually you can scale up. You can resize the warehouse if needed. Now you have to specify the name of the warehouse. So let me just call it demo WH, and then you have this option of minimum and maximum clusters for the warehouse. Now this is pretty much important because if you want to utilize the power of scaling out strategy, you will have to define maximum clusters other than one. So that actually means that this particular warehouse will scale from one virtual cluster to up to 2 clusters if required. So whenever your number of users and the number of queries grow, and Snowflake will notice that some queries are being queued, it will just add additional clusters to this virtual warehouse. You can specify the maximum number of 10 clusters per each virtual warehouse. Now, scaling policy is something that is responsible for the speed with which this virtual warehouse will scale out. So standard means that if Snowflake sees that the queuing occurs, it immediately scales out the virtual warehouse, so it adds additional clusters. While economy will stand for the situation when Snowflake waits for 6 queries to be queued, and then it scales out the virtual warehouse appropriately. Now, I'm going to leave this policy to standard, and there's a very important option of auto suspend, because you don't want to pay money for this virtual warehouse if it's not used. So Snowflake brings this feature, which I can set down to 5 minutes. So it auto suspend this warehouse for me whenever 5 minutes of inactivity in terms of querying occurs. And it will also auto resume whenever the new query comes in and the virtual warehouse is suspended. So with that, I can show you also the SQL code that is going to be executed in a moment. And I will just create this warehouse. As I mentioned, using Web UI, if you create the virtual warehouse, this warehouse is going to start by default. I will just suspend my warehouse. As you can see, suspending and also resuming the warehouse is a matter of milliseconds. So Snowflake allows you to just easily manage the virtual warehouses within sub-seconds. Also, if you want to scale up, you can easily do it using this Web UI, and the scaling occurs pretty fast. So this is also a matter of up to 1-2 seconds to scale up, scale down. Now, let me show you what does it mean actually to scale up the warehouse. So I'm going to use my analytics warehouse, and I'm going to resume it. So I'm just going to make sure that my warehouse is running. Now, I'm going to show you executing the same query against different sizes of the warehouse to make sure that you understand that scaling up is for performance. So to make things meaningful, I will set this session to not use the cache results, because otherwise this query will run in the milliseconds whenever I run it for the second and further times. So I will just disable caching for result caching for the moment, just to show you the same query executed several times without caching feature. Now this query is using the TPCH data. TPCH is a benchmark for data warehousing workloads, and vendors can participate in this benchmark to prove that their data technology provides performance and price per performance ratio. So let me just show you this table from the size perspective, because it's pretty much interesting. So I'm going to run this queries against nearly 50 gigabyte table, which contains 1.5 billion rows. So pretty much significant data. Now let me run this query, and let's see if it completes in under 30 seconds. So let's assume 30 seconds is my SLA, the maximum acceptable time for running this query. This query actually is pretty simple. It does some aggregations on top of the whole table. So it takes my 1.5 billion rows, it excerpts the year from the order date column, and it summarizes total price. So it brings me actually the revenue per year information. And also it does some ordering to provide me the data in a sorted way. So as you can see, 30 seconds is not enough for this query to run using my XSmall data warehouse, a virtual warehouse. So I'm going to abort this, because I'm not going to wait over a minute to finish this query. And now let's resize this virtual warehouse to X large size. So as you can see, I'm going to move through small, medium, and large. So it's actually 8 times bigger virtual warehouse than before. And as you can see, suspending, resizing, and resuming is immediate operation. And now I can run my query again. And let's just wait a couple of seconds, because it completes in 6 seconds, as you can see. So it's definitely faster than executed with XSmall virtual warehouse. I'm not sure how much faster, because I didn't allow this query to finish previously, but definitely at least 5 times faster when I'm working with XLarge virtual warehouse. So that's how scaling up for performance looks like. And as you can see, I didn't create any kind of optimization objects like indexes, partitions, or something like that, because Snowflake provides you near zero management features like micro partitions that are used for storing data, and virtual warehouses, as you can see, that can be scaled up for performance as well. So whenever I want to complete any query faster, the first thing I should consider is probably to resize my warehouse and try that. Now let me run the load test to prove that the automatical scale out works fine in Snowflake. So analytics warehouse is configured in a way that it starts from one cluster, but also it can scale out up to 4 clusters whenever needed. And please note that the scaling policy for this virtual warehouse is set to standard. So it will scale out immediately after any kind of queries being queued. Now let's run some load test on top of my warehouse. But before I do that, let me switch to the history of the queries. And let's add some filter just to make sure that I see only filters that are being run during my load test. So I'm going to add query tag filter, and my queries will contain demo keyword in the tag. So as you can see, I ran this before. So I will just switch it to demo 1 maybe, just to make sure that I'm not hit any previous tests. So demo 1 will be my query tag for the running queries. Now let's move to the test. I'm going to run some random queries. So this actually will refer to the same TPCH data, but I will run some random parameters on top of the query. So this query actually will never be the same. It will ask for different parameters each time. But let me just make sure that my query tag is demo1, and I'm going to save this file. Now, the test is pretty much simple because it will run 30 times the same SQL scripts on top of my Snowflake account. So I will each of this line connects to Snowflake and runs the SQL script I've already shown you before. So let me run this test. And let's get back to Snowflake to make sure that I see that the newly executed queries are coming. So it takes a second, but in a moment I should see my queries running. Okay, so you can see that I have several queries running, and let's check whether my warehouse scaled out for concurrency. As you can see, yes, the analytics WH scaled out to 2 active clusters of 4 possible, because it had to respond to the growing number of users, growing number of concurrent queries. So that's how virtual warehouse react in order to address some concurrency challenges. Whenever a peak in the workload happens, you can see that your virtual warehouse can scale out. Now, this is the feature, the multi-cluster virtual warehouse is the feature of enterprise and higher editions of Snowflake. So keep in mind that in standard edition of Snowflake, you will not be able to create this multi-cluster virtual warehouses. So if you want this feature to have in place, take care of your Snowflake edition and make sure that it's at least enterprise. Now, I can also see the history of my workload running on top of my warehouse. So here is the peak of the queries. You can see that there were some queries being queued in the warehouse, and probably at that time my warehouse had to scale out because this queuing occurred, and I have my standard scaling policy set up for the warehouse. Now those queries probably were probably completed. Yes, so as you can see, lots of very similar queries were run on top of the analytics warehouse. They all ended up in some acceptable time, 24 seconds, but that was just because I scaled out my virtual warehouse. I allowed my virtual warehouse to scale out automatically. So as you can see, virtual warehouses in Snowflake are pretty much powerful thing, because with them you can use not just their size in order to speed up your queries, but also you can scale out your clusters to be ready for some unexpected workloads like Black Fridays and so forth. You can also separate your workloads using different virtual warehouses to make sure that ELT processes and, for example, sales analytics will not work on the same compute power. In the next episode, I will show you how to work with roles and users in Snowflake and how to deal with security, which is crucial in the cybercrime era. With that, I hope you enjoyed this episode, and subscribe the channel, watch us. Thank you.